Alright, ladies and gentlemen, welcome to a quick overview of everything vectors. We're going to use the review to go over these things for you. Let's start at the beginning. On these first ones, you need to get the component form of the vector, and the way to do that is you figure out where the vector started and where it ended, and find the change horizontally and find the change vertically, which would be the change in x and change in y, and then you put it in a couple brackets just like this. And so on this first one, you just count how much to the right it went, and you count how far it went down, and you're looking at, here, let's just quickly count that. 1, 2, 3, 4, 5, 6. So it went 6 to the right, so I put 6, and then went down 1, 2, 3, 4, 5, 6. And I'm not going to put positive 6, I'm going to put negative 6. So you have to remember that positive in the x spot means going right, and then positive in the y spot means going up. So this is going right and down, positive x, negative y. And you do the same thing here. You need to know the initial point is where it starts, and the terminal point is where it ends. And so you figure out what's the change from negative 3 to negative 5. Well, that change is going left 2, so your x part's going to be negative 2. And then you figure out what's the change from 2 to negative 1. Well, to go from 2 to negative 1, you have to go you have to go down 3. So I'm going to put negative 3 there. That is the y, so that's vertical. So there we go. We got a couple of our component forms here. Next one, going from 9 to 0 is going down by 9, so negative 9 first there. And then from 3 to negative 4 is again going down by 7, so negative 7. Please don't make this think that your y always has to be negative. These ones just happen to be going down in the y direction. Alright, let's move on to our next section. This is vector operations. This is where you can take different vectors and add their parts together. Let's actually start with 10, and then we'll do 8 and 12. So on 10, these two vertical lines around it means get the magnitude of it, and we'll get there in a moment. But let's do this inside part. V minus a. So you have to take the vector v and the vector a and subtract those two, which is going to turn to negative 4, 6, minus negative 5, negative 1. And the way to do this is you're going to combine the x's together and combine the y's together to make your two new components of your vector. And you have to remember that we're subtracting here, so you may want to distribute this subtraction and change the signs here, so it becomes a lot easier. So we got negative 4 plus 5, which is going to make 1. That's a bad bracket. And then we got 6 plus 1, which is going to be 7. That was a terrible 7. So here's our resulting vector. Man, my brackets are looking bad. From here, you need to get the magnitude. That's those two vertical lines around it. The magnitude of a vector is the length of it. And the way you get that is you take your two components and you square them. I'll make sure we put them in parentheses. Man, these are looking bad. Parentheses. You square them, add them together, and then you square root it. It's like you're getting the distance of it, the length of it, using your Pythagorean theorem. 1 squared plus 7 squared is 50. So this is the square root of 50, which is about 7.1, if I remember quickly. So yeah, square root of 50 is the exact one, and this is the approximate. So there you go. So common basics. If you're adding two vectors, you combine the x's together and the y's together, and then to get magnitude, that's those vertical lines, you square each part, add them together, and then square root it. So let's jump to 8. On 8, it's got 3a and 2c, so I can put 3 and then a minus 2, and then what c is, which is 0, negative 3. And I'm going to distribute, so the 3 in front of these, this, and the negative 2 in front of that. Let's, you can distribute them. So I'm going to distribute. And I'm going to be distributing negative 2. So it's like plus negative 2 times that. We get negative 15, negative 3. And then plus 0, 6. And now I can combine my x's together. Negative 15 plus 0 is negative 15. And I can combine my y's together. Negative 3 and 6 makes 3. So voila, I got my answer there. On this last one, I'm going to do 2 times a, which is negative 5, negative 1, and get the magnitude of that. And then we need to add the magnitude of negative 3 times c, which is 0, negative 3. I got some extra marks here. Let's get rid of those. So yeah, you want to distribute inside and then get the magnitude on each of these. So they'll give you a negative 10, negative 2. You want to get magnitude plus magnitude of 0, 9. Remember, to get magnitude, you're going to square both of them and then square root it. So this is really kind of turning into two different problems that you then combine at the end. So this part here is going to be square root of negative 10 squared plus negative 2 squared. That's supposed to be a bracket, 5. And then plus the square root of 0 squared plus 9 squared. I'm putting parentheses because you do have to be careful about signs. If you don't put the negatives in your calculator, it tends to get the wrong sign at the end. So make sure you put parentheses around it. And that's going to give you, take a moment, I'm going to put that in my calculator so you can check it. Alright, it's looking like square root of 104 plus the square root of 9. Square root of 9 is 3. Square root of 104 is about 10.198, so yeah, you're going to add those together and you're going to get about 13.20. I'm just rounding to the second decimal place, which rounds to the first one. So we're looking at about 13.20. Make sure you know how to use a calculator to get square root and square things. That makes a difference. All right, and then we've got these problems where you have to be able to model this situation with a vector, and then you'll end up getting velocity or speed, and that's a magnitude for it. So 14, James rides a car from his office. He goes east at that much and south at that much. So those are the two components of our vector. If you think about, like, he's going east 60 and then south 50, and that's going to, sorry, it makes a vector looking like this. And so since we're going right, we're going to say that's a positive 60. Since it's going south, we're going to say it's negative 50. Whether it's positive or negative just depends on your frame of reference. But normally, north and east, we're going to say positive, and then south and west, we're going to say negative, just like on a coordinate plane. And from here, you're going to get the magnitude of this, and that'll give you the velocity. So you'll need to get 60 squared and add 50 squared, well, negative 50 squared, and square root it. That's a bad-looking square root, but we'll make it work. Yeah, so you just plug it in and you get your values there. Alright, we're looking at my square root of 6100, which is about 78.10, and there's our final result. And the same thing's happening down here. It's like north at 30, north is vertical, so put 30 there, and then east at 22. And then what's the relative velocity there? Well, you're going to do the square root of 22 squared plus 30 squared. You put that in, 22 squared plus 30 squared. Looking at square root, it has to be square root, 1,384, which comes out to be about 37.20, and that's in meters per second. And voila, we got our final speed there, a little bit over 37 meters a second. Alright, so now we got our last section here, which is about transformations using matrices. So you can take a vector and transform it using a matrix. And to do this, I highly recommend that you have your note paper handy, which, if you're wondering what that looks like, it looks like this. This is in the module on vector transformations. You just pull up those notes, and that's what this is. This is very handy because it tells you what the transformations are, and it tells you what matrices do what transformations. So if you want to rotate 90 degrees clockwise, you use this matrix, and it's going to do this to your vector. And so you can use that to help you out. So first one here, we got this lovely vector, and it's being times by the, actually, let's do 20 first. It's a little bit easier, and then we'll jump to 18. So on 20, we got this lovely vector and then this matrix. So look on your note paper and find this matrix and see which one it is. Oh, it's this one. And this is a transformation that rotates 90 degrees around the origin, which you're going to take your xy, you're going to switch positions, and then change the sign on your new second coordinate. So I'm going to take this, and I'm going to switch the order there, and I'm going to change the sign on my new second coordinate, just like it says here, and this is a rotating 90-degree clockwise around the origin. So I'm going to write that down as rotate 90 degrees clockwise, into that W, about the origin. Awesome. This one up here is not on that table, but you can find on your table a matrix that looks like the same thing, but with ones. And so yeah, go ahead and look at your notes, find the matrix that looks like this, and see which one it is. Well, that's going to be this one here. And this is a 90-degree counterclockwise. But if you look at our original matrix, it doesn't have ones, it has sixes. And what that does is this is also dilating by a factor of 6. Factor of 6. And it rotates. That's rotating 90-degree counterclockwise about the origin. So to take any vector and dilate by a number, use times by that number. So this is going to turn into, when you do the dilation, you're going to times them both by 6, which will give you a negative 18 and negative 24. And then you're going to switch the order, just like it says here on rotating 9 degrees counterclockwise. XY becomes YX, and it's negative YX, so we're going to change the sign on our new first coordinate. So switch them, and then you got a new first coordinate, and voila, you have successfully transformed your vector using that matrix. Let's jump to the last section you need to be able to do, just so you know. The bottom section you do not need to be able to do for your quiz. This last one here, you need to figure out what matrix makes this vector end up looking like this, and we're going to also describe the transformation. So right here, you look at it and be as observant as you can. We got these XY coordinates, and how do they change at the end? Well, it's looking like we had 2, 8, and now we got 8, 2. So we're going to switch the order here. We got Y, X. And it's not just 8, it's negative 8, so the Y got a sign change. So you need to look at your notes and figure out what transformation made XY go to negative YX. Well, we actually just did a problem that had that, and that's the rotating 9-degree counterclockwise, which is going to give us this matrix, and that's going to do it. So we're just going to copy it down, 0, 1, negative 1, 0, and we have successfully written the matrix that's going to do that transformation, and it's a 90-degree counterclockwise rotation. And we got one last one. Let's see, 24 here. We got negative 3, negative 5, and now it's negative 5, 3. Well, so this one's really similar to the last one. We had XY, and then we ended up switching the order again. So we got Y and then X. But the X changed sign, so it was negative 3, now it's positive 3, so X is getting a sign change this time. Once again, you can look at your notes to figure out what transformation that is. This one is actually this one here. XY goes to Y negative X, so that's a 9-degree clockwise rotation, and it has this matrix here. So your matrix is going to be 0, negative 1, 1, 0. And that's rotate 90-degree clockwise. So there we go. So yeah, there you go. Just so you know, there's not only just rotating. There are other transformations you can do. Unfortunately, we didn't have any reflection ones. But yeah, if yours vector components are the same order, but there's a little sign change, then you're looking at a reflection. All the reflections have the numbers in the same spot, but the signs have changed in some way. And that's what these are, and these matrices do those. And if you have a dilation, like all your numbers get bigger by times by the same number, that's a dilation, and it's gonna be just whatever that number is. You put that number instead of the 1 there in your matrix. And so there you go, quick overview Hopefully that helps you out.